So, what we're talking about today is reflecting shapes over a particular line, and then actually translating as well. So like I said, if we have to shorten this, we can. We'll kind of see how we do on time. I'll leave you at least 15, 20 minutes to work on homework. So just we'll kind of use that as our baseline for when we'll be done. But again, I think the notes look longer than they are. So hopefully that's the case. So it says the graph the following line. So y equals x. What is that line going to look like? Y equals x. Where would that start from? What would that line look like? It starts at 0. So this line, because it's really like a plus 0, so begin at 0. And then what's the slope for it? I don't know if you said the right thing this time. What's the slope? Anyone know? What's in front of x? A 1. So the slope is 1 over 1. I don't know if that's what you said. But so it's up 1 over 1. So this is my y equals x line. This is one of the lines that we're going to be using to fold our graph over this line. So it's a very important line because it goes diagonally through the middle of the graph. So that being said, y equals negative x. What's that going to look like instead? It's going to be the downhill version of that. So now m is negative 1, still begins at 0, so we're going to go the other way. And then finally, y equals 2 is going to be a flat line at 2. So our y equals 2 line would be a flat line. So just trying to remind you guys of some of these lines that sometimes I think easier graphs are more confusing because if it's in that like y equals mx plus b form and everything's there, sometimes it's easier to identify what everything is. So these are some basic graphs that sometimes get confusing for us. So we're going to talk about reflecting an image, so like it's going to flip over one of these lines, and then also maybe combining more than one transformation. So we might do a few things to our equation. So that being said, let's get into that. So our first one, we kind of did this one the other day, is reflecting over the x-axis. But there's a rule for it that maybe might be helpful just to know, just because there's, it might get confusing sometimes when we're drawing these. So I'm going to graph this. So 2, 3. So this is my first, this is the pre-image. And I want to reflect that over the x-axis. Now, if you're not great at visualizing that, like saying, well, this one's up 3 over the x-axis and this one's down 3. So like if you're looking at this, if I'm trying to reflect 2, 3, I would go just down 3 instead. So basically what I'm doing is I'm keeping the x the same and I'm doing the opposite of whatever y is. So this is the rule for this. Sorry, I know it's hard to see around my screen there. So this is our rule, is that I'm leaving the x the same, but the y is changing its sign. So if you want to think about it that way, so like the new w, the 2 would stay the same, but the 3 would flip. The 7 would stay the same, but the 3 would flip. Now, if it was a negative 1, it's going to become a positive 1. It's going to flip over that axis. And so being comfortable with that rule, that idea that that's going to flip it over the axis, this might be a good thing to be aware of. All right, so we're looking at the next rule. Now the y-axis, again, we did this one already, and you might have some like a guess of what that rule is going to be based off our rule for the x-axis. Remember the y-axis is the vertical axis here. So I'm going to reflect this shape over that axis. So again, I'll draw it first. So again, it's kind of this little trapezoid type shape here. So now we're flipping it over that purple line. So it should come over and flip over this way. So again, like we talked about, you might be able to just visualize where that would be. But if you kind of use the conclusion from last one, we changed the value of the y. This time we're going to change the value of the x. So the y is going to stay the same, and the x is just going to flip. So it's going to be a negative x, and whatever the y is, so the y will stay the same, and it's the opposite sign. So basically, that's what this means. So like my h prime, the x was -2, it's going to become a +2, 5. So 2, 5. So this one actually overlaps onto itself. Whereas this one is going to be a negative. So those 2 points are actually reflecting right on themselves. So that's kind of interesting or different here. But now this next one, you change the sign of the y, the x, sorry, and leave the y the same. Oops, I didn't go pi on there. So our mirror image, again, flips over, kind of looks like, I don't know, like wings or something on the other side. But these rules might be helpful for some of you who aren't as visual as others. Like if a rule makes more sense, that's perfectly fine to like use that rule. So our next reflection we're doing is over the y equals the x line. So we're kind of reflecting this diagonally. So the y equals x line, we learned in the warm-up, or we remind ourselves in the warm-up. Hopefully we didn't learn it for the first time in the warm-up. Our y equals x line is this line here. So this is my reflection line. So that's the line where I'm reflecting this over. And again, that means it's going to flip like diagonally. So I'm going to graph my first one here, my f. So this little triangle is going to be flipped over that red line. And you could spend some time trying to guess where that would be. I think I'm just going to give you what the reflection is to not make you like have to try to figure it out. Basically what we're doing is it's saying y equals x. So basically what we're going to do is we're going to flip the 2 coordinates. So if the coordinate was x, y, now it's going to be y, x. So you're going to flip where they are. So it's just going to turn this coordinate around. So you're not going to change the sign at all. You're going to flip it. So it was 0, 4, now it's 4, 0. So it flips over that y-axis, so diagonally. And so it's just a matter of determining which of these rules that is giving us. And I'm telling you guys, you don't necessarily have to follow the rule. If you're very visual and you can like picture what that point should look like, perfectly fine. I think some of these more complicated ones, though, it does help to have the rule. Right. So our next one is we're reflecting in the line y equals negative x. So this is the downhill slope one. Whoops. So this is our line that we're reflecting in. So obviously it can't be the same rule as the last one where we switch the x and y. What we're going to do is we're going to switch the x and y, and we're going to change both of their signs. So they're both going to flip, and they're going to change their signs. Now this is a little bit annoying because the coordinate points aren't listed there for us, so we have to like look at what the coordinate points are. So like A is -2, 7. So that means the flipped version of A. So what you do is you flip the x and y and you change their signs. So it becomes, it was +7 as the y, it's going to become -7 as the x. It was -2, now it's going to become +2. Our b was -4, 2. So flip them and change the sign. And then our C is 0, 2. So flip it and change the sign, so -2, 0. So just flipping over that other axis. And once you draw it, I'm thinking you're like probably like, oh yeah, that seems to make sense. But initially, like I think it's hard to visualize what it should do. Okay. All right, the next one, there's gonna be some that you need to reflect over that they don't give you a rule for. But I think, again, you can use a little bit of logic with this and hopefully visualize it a little bit more. So like y equals 4, they don't give us a rule for this. I don't know of one to explain how we would do it, like in a rule. So I'm going to draw the line at y equals 4. And so what I'm basically going to do is mirror the point above and below it, using that green line as kind of my border line. So A is 3 above. So we're going to go 3 below for A prime. B is 2 below, so we're going to go 2 above. C is 2 below, so we're going to go 2 above. So we kind of end up with a little star here. So that's those reflections. Again, if the rules are helpful, feel free to use them. If they're not, feel free to use your logic to do them. Again, I don't think it's too tough of a lesson in terms of those. I would like to kind of touch on the next part, just to show you guys that we can do more than one movement. We probably don't have to do all of these, but like I said, let's work for another 5 minutes, and then I'll let you guys have homework time to see how much we can get done. So it says to apply compositions of transformations. All that compositions mean, it doesn't mean we're writing a paper. Sometimes compositions are a paper. It just means multiple transformations. And so that basically means like maybe we're doing a slide and a reflection, or like a slide and a dilation or something like that. You could have to, or a rotation. We didn't really do much with rotations. They're a little harder to show other than just that it rotated. So just know that we won't do a ton with that in what we're doing. So we're going to do two different things here. We're going to move, so we basically have to move this twice. And so it's up to you guys if you want to even write the original. I don't know. So I probably will. I'll probably write the original in like light gray or something like that. So I'm going to graph this. Oh, it does say to graph it. But so I'm going to graph this. I think this helps me when I'm like grading things to make sure you have it even in the right spot to begin with. Like for instance, like Mia asked me about her homework quiz today, and one of her points she had just written down wrong, but it's hard for me to know what you're doing wrong if I don't know where you started from. So this is my original. And they want me to move it twice. They want me first, and the order does matter, I believe. I'm trying to think of, I would think it matters, so we're going to stick with it mattering or thinking that. We're going to move it first as a translation, and then next as a reflection. So we're going to do both movements. So our first movement, we're going to move it left 3 and up 2. And they might use some of our different notations we've learned, just kind of depends on the problem. Again, if you want to write the new version, so left 3, I would subtract 3 from that, and I would move that up 2. Subtract 3 up 2. Subtract 3 up 2. So this is our translated version, which we've done already. We know how to do that. Now, if you want to describe the final one, since we're moving at another time, they just give it another tick mark. So we're flipping the x and y. So we call it t prime prime, or t, I guess, that, like, comma, comma, or apostrophe, apostrophe. We're going to flip these two, remember. And kind of, these are probably tougher to visualize if you're doing it correctly or not, just because it kind of gets a little bit jumbled with all the things on it. But if you look at the purple and blue only, hopefully you guys think that looks like it's flipped across that y equals x line. And I'm just going to take a quick minute to show you guys what they're asking me to do on the bottom. Everyone has that. So all they're asking you to do is describe the translation. And remember, the original would be the one without the little like apostrophe by it. So Q translated over. So I would say that it flips over the y-axis. So that's just you're explaining that, or a y-axis reflection. And then if you look at this one, they move it twice. So it's sliding here, but then they rotate it down here. We didn't do much with rotations, but again, just kind of trying to notice if they're moving it more than once, and just describing that. So again, it doesn't take a ton to just like write that or explain it if you can tell what they're doing. So I'll get you guys a worksheet that goes with this. Again, this is our homework for grade. We could probably, let's see. Yeah. Some of these are just true or false. So I'm hoping that it looks longer than it is, kind of idea. Yeah.
Just die.